we're gonna see crack of a plane. Huh? So let's import the geometry of this, which will be like 2D planar, which is deformable. Let's import it, and then let's import the rigid that we have created. So just look at rigid. Okay. So we'll import as a discrete rigid, and then we just 2D planar, and then let's go for it. Okay. Then property, let's create the property of a steel with density. Sorry, let's take density of 700, and then mechanical elastic, which is 200 e power 9, and then 0.3 of Poisson ratio. So now we have created the thing, and then let's create a solid homogeneous with the brain stress of from done. Let's create section and done. Material is assigned. Let's import in assembly. Let's import the part, both the part, and then independent. Okay, done. Now let's arrange the thing by, let's take rotate. Let's select this. Done. First and foremost, we need to actually circle it out. Let's create it done, and then let's make it as 2, and then 180. So we have one model, and then let's translate each. Like take this, done, done, minus 0.15, and then comma, minus 0.04. Okay, then it goes to its place now. Okay, then linear. So let's take this, done. Let's do the pattern of 2, distance of 0.08, and then give okay. Let's go for the bottom one. Same way, let's do a pattern of this, done. So which is 0, and then over here we can give a distance of 0.18, which goes at the last. Okay, so now the preparation of thing is done. Though everything is on the set, so we need to create one planar thing that which actually help us to create the uh, crack simulation. Okay, so let's create lines that we take this. Let's create the distance that it's supposed to be 0.003, and then the distance from here to here is 0.03, and then the distance from here to here it will be 0.003, and then the distance from here to here it will be 0.006. Okay, now let's take this and then trim excess lines. So this will be excess lines that we need to trim it out. So we have the code thing. So let's check distance. Yep. Now we are good to go. Dimensions are done. So now we have created the section that we want. Okay. So let's create the circles that we want. So let's create a circle like this. 1, 2, 3 for now, and then let's create 0.0003 75, and this will be 0.0000375 star 2, and this will be 0.000375 star 3, and need to create two more. No, no. Two. So let's take this one and 0.000375 star 4, and then this will be 0.000375 star 5. Okay, so now we have created the rings. Then we need to create a sufficient line like this, and this, and even need to create a small subdivision line towards the top here. Now we have created it, and okay, now you can see that we have created the area that we wanted. So let's create some sets so that will be easier for the next things. So let's create tools, create sets, and then create. Let's create an edge. So these are the edges that we need to take it out. Let's select these edges till this point. So and then done, and then again we'll create one more set for cut point. Okay, so we'll take this point as a cut point, done, and then we will create arc circles as a set. So arc circles. So we will consider edges, and then we will consider these. So we'll consider these edges, these arcs, done, and then we will need to consider some diads. Okay, so tools, sets, create. Let's take a circle dia. Okay, so circle dia means it's again edges. What we'll do, we'll actually consider this, and then what to remove this. So you'll see at end of the process, it's pretty easy to select such a way on this method. So we have created, uh, took this diagonal and done. Okay, now then we will actually go for interaction. So way before that, we'll create a step. So step of a static general, which geometry in the on, and then specification, and then other things are little bit okay, not good to go. And then let's create one more step, uh, which will be crack with the contour of um, 5. Let's take stress and geometry. Okay, do what that will be better, and then let's stress and geometry. Crack domain data is missing. Okay, so let's go to interaction. Will create the crack domain. So crack, assign scenes. So let's take sets. So use this edge for this so that you can see the highlight adjustments. And then now we will create crack, create. So we are creating integrals that will be like the crack point. So, okay, so that's it. So we will create a queue. So it shows the vector of this point, and then this point it should choose upwards, and then that's what we want, and then symmetrically, and then this is supposed to be going 0.25, and then collapse the elements to the side edge. That will be way better. So that's good since we have assigned it. So get back to step and then recreate what we have tried to create earlier. So go over here, whole element into drag, and then now we have crack one over here. So this is what we required initially. So next it will be stress and the number of contours that we can give 5. And over here, like, okay, done. So now we have created the contours output, history output, and then let's go back to the interaction. So it helps to need to create the our bodies that we want. So before creating our bodies, we need to create reference points for each of these. Okay, so let's create that and then create the R bodies that we want. Let's create body of elements, select these, done, and then point this. Okay, and then create scene way for each other things. So body, let's create things. Okay, let's create this point, done, and then same way again, body, done, a reference point. Okay, and then let's create one more last one. Right, all the reference bodies are done. So let's create a property of a contact. So thermal behavior friction penalty of with the friction of 0.2 as friction. Let's create the let's put it on initial surface to surface contact. So let's have this as one, and then which is magenta, and then the surface line will be this. Done. Okay, now we have each and everything like good to go. Now let's create four more respective to that, which is magenta again. Surface, select this, done. Okay, then create two more surface to surface contact, create done again magenta, surface, select this, done. Okay, and then let's create this, done, magenta again, and surface, click this, done. And we got properties. Now interactions are done. Let's go to create the load. So let's create the symmetrical thing on this too, right? Okay, so these are the two boundary condition area done and cast. Right, let's create displacement symmetry at the initial, which will be these two, done. Okay, manager, go to it and then edit it. So that will be 0, this will be minus 5 e power minus 9. So fine, that will be better. So done, and then you can see we have given load. Let's go to mesh. So mesh, it is kind of a critical thing that we need to go with global size of this point of point 2. That will be okay. Since we have the this removed, so I'll measure all these lines which we have created over here. So this require that we will go for 0, 1. It will be applicable since it is a discrete rigid. If it is analytical rigid, you doesn't need a mesh since it is a discrete rigid. So we require a mesh to mesh it out. So let's take this and we have meshed it. We'll return it, and then now we have given all those things in spite of that, now we are going to pick the circles that we have created earlier. Continue. Let's go to by number. Let's increase 4 and then a circle dia. Let it be 1. Okay, right? Right. Now what we are going to do is assigning things. So since this area that we are going to take that trial as free, right? Okay, and then the other area like this. So these areas that we are going to take as this area and then this area, this, and we are going to create quad as sweep. Okay, so let's take the rest of the area that you can see quad mid-axial as a free. Okay, so done. Once we are done with it, we will actually mesh it. So complete mesh. So now you can see a little bit hanging over here. If you uncheck this, you can see all those things and then you can see what it has done. So that you can see that there is a split over here, which is actually like this. Okay, the dia is like pretty much over here. That's why it actually shows like that. Ain't a problem. So we will achieve what we want. So since all these are over, so let's assign this. So entire thing done. So we are going to give quadric, strain, yep, plain strain quadric, and then for better results. So yes, okay. And then let's take the other parts, these parts, and then let's go for hurry. So it's pretty in our sign. So let's go for job and then let's create a job called crack. That's better. Personalize and then now let's run it. Let's look into the monitor. Now you can see the learning has been completed. Let's see the results that we want to see. So let's then see that we can see only over here that actually has very high stresses which crash has been initiated. So let's go over here and then uniform let's set to 10. Apply that you can see that the thing has been created, the edge that has been moved outside, which will actually shows the crack bookings. So you can even see stress and then what heart waves and then even in the feature list. So you can see that how it's actually being seen over here. So that's for today. Thank you.